Algebra 2, here we go with 7.2 exponential graphs. Exponential graphs and properties. All right, so we have an exponential function, f of x equals b to the x. Okay, so this looks a little different than our other ones that we've done because, the other ones we looked at were y equals a times b to the x, or a of t equals a b to the t, what have you, okay? But this is the most basic one, and this is actually the same as these. You're going to see lots of different versions of these, whether it's in function notation or whether it's written in terms of time versus x. They're all the same thing, but this one just doesn't show the a value, but this has an a value of 1, okay? This one actually has an a value, an initial value, this right here of 1. Okay, so the base, the multiplier, b is the multiplier. The multiplier is always going to be greater than 0. You're going to be doubling or tripling or quadrupling or halving or, 1.05 or 90.98. You're never going to have a negative here. It just doesn't make sense. So you're always going to, just for exponential functions, this base will be positive and the base is not going to equal 1. 1 to any power would be 1, and that's just not exponential. Okay, so b is your base. All right, so let's graph an exponential equation. So this is exponential because the variable is in the exponent position. So 2 to the negative 3, we're just going to plug in 2 to the negative 2, 2 to the negative 1, 2 to the 0, 2 to the first, 2 to the second, 2 cubed. Okay, well 2 to the second is easy, and 2 to the fourth is easy, and 2 to the third is easy. All right, so let's go backpedal here. So anything to the 0 power is 1. Okay, anything to the 0 power is 1, great. And now, what does this mean? So this is just 2 to the first power, but the 2 is going to get pushed to the denominator. So that's just going to be 1 over 2. Same thing here, 2 squared is going to be 4, but it's going to be in the denominator. And 2 cubed is going to be, 8, but that negative pushes it to the denominator. So let's see what this looks like on the graph. So if we're at negative 3, that's really, really low, that's low, that's, low. And then we hit this really big key value here. This is what we would call a key value on the exponential. All right? And then we go 1 is at 2, 2 is at 4. Let's see, 1, 2, 3, 4. I'm a little high there. 2 is at 4. And then 3 is 8. So it's getting exponentially really big, really quickly, and that is the nature of exponential functions. So there is your basic parent function for an exponential function for growth. All right, key value of 0, 1. Please note that key value of 0, 1. So let's go over here and look at this different basis now 1/2. Okay, so negative 3 to the, 1/2, sorry, that's the exponent. 1/2 to the negative 3. 1/2 to the negative 3. Oh my gosh, negative 2. Sorry, my phone is over there beeping. That's what's distracting me. 1/2 to the negative 1. 1/2 to the 0. 1/2 to the first. I'm a little bit off here because of the fraction. 1/2 squared and 1/2 cubed. All right. So again, right in here, anything to the 0 power is 1. So that's that key value once again, that key value. And now let's see, so 1/2 to the first power, that's easy. That's just 1/2. This is just 1/4, so at 2. And then at 3, this is just 1/8, okay? All right, but on the left side, so this 1/2 to the first power, it's going to reciprocate that. So this is just going to be 2. This is going to be 2 squared, but reciprocated. And this is going to be 2 cubed, but this negative says, hey, reciprocate. So now on the left-hand side at negative 3, I'm at 8. At negative 2, I'm at 4. And at negative 1, I'm at 2. All right, and so that's 0, 1. key value right there. And this is the parent function for decay. This is the parent function for decay. So one is growth, and one is decay. And look at the difference right there and right there. Okay, so some properties with this. All right, conclusions for exponential growth. Now notice B can't be 1, so this is when B is greater than 1. B can't be 1, so 1 greater than 1. So the multiplier of the base might be doubling, tripling, quadrupling, 2.5, what have you, anything bigger than 1. Notice the domain is everywhere, everywhere left to right. Here we go. X values are covered, so this is all reals. The range, the Y values are always above the X axis, so Y is greater than 0. So the graph is above. The key value here is that 0, 1. That is the key value. Okay, so if you look at here, that's your initial amount. So right here, this is really f of x equals initial amount and then 2 to the x. That's your A value, that initial amount. When x is 0, that's your initial amount. At 0 time, what have you, there's your initial amount. All right, the graph is increasing. If I were to walk along it left to right like you would read a book, I'd be going uphill, so that's an increasing graph. And now what's going to happen long term right here is these values are going to just get to be teeny tiny little fractions all the way to infinity. But they're never going to zero out. Never, never, never going to zero out. So they're going to just run along this line, and this line is what we call an asymptote. Think of it like a fence, and this is a fence in the graph. On this left-hand side, it's just going to run along that fence. So that's an asymptote, kind of a fun word to say. And the asymptote is that x-axis, which is on the left-hand side, which is y equal to 0 is the equation for that. All right? So left-hand asymptote of y equal to 0, the graph just approaches it but does not touch it. Very similar properties over here on the decay. So exponential decay. So now, remember B can't be 1, and B is greater than 0. And where am I getting this from here? Okay. So these are just for those values between 0 and 1. So 1/2, 2/3, 3/4, those kind of things. So again, domain, X values are everywhere. There's X values everywhere. Okay, as long as we go left to right, so this is all reals. But the range, again, is above the x-axis, same as growth. Key value is the same. The initial value is the same. This function is really a function of x. 1 times 1/2 x. All right? So this graph is decreasing. If you were to take a walk on that, you'd be walking downhill. That's a decreasing function. I'm going downhill. And this has a horizontal asymptote at the y equal to 0. But this is on the right-hand side. All right? So this asymptote, it's kind of like a settling down of y values. So the y values will settle down to this asymptote right here. Okay, so using the calculator to graph these here, hopefully you can note that these are all growth because this is bigger than 1, bigger than 1, bigger than 1. And we're going to see that the larger base is going to have faster growth. Certainly that makes sense. These numbers are getting really big really quick, and if you give a bigger base, they're going to get really big even faster. So certainly that is sort of common sense to us. But let's let the TI take care of this. Okay, oops. All right, clear. Let's clear all that calculus out of there. Okay, so let's do 1.2 to the x. So that one's going to graph first. Okay, and then let's do 2 to the x. When I push graph, that one's going to graph second. And then let's graph 3 to the x. And when I push graph, that one's going to graph next. Okay, so watch the graphs. Oh, I'm going to zoom. I'm going to do a Sorry, I've got my window here fixed for some other problem. So it's thinking, it's trying to do this. All right, so let's go zoom 6 to a standard graph. All right, here we go. So here comes the first one, going through the key value. So this is the 1.2. And then here comes the 2. And then here comes the 3. Okay? So they're very similar because they all have this key value and they all have the same shape. But that is going to be the 1.2 farther away from the x and the y-axis, if you will. And the next one's going to come in here. And then the next one's going to come in here. All right, so this would have been the 3 to the x, and that's the closest, and the closest to the axis because it's the bigger number. This is 2 to the x, and this is 1.2 to the x. That's going to be farther away on both ends to the x and the y-axis. They're very similar shapes, but that's what the TI showed us. All right, so let's do some transformations on these. All right, so this is just now you have an initial value. That's something other than 1. All right, so here's the original. This is just y equals 2 to the x. So this is going to be a vertical stretch by 3. So let's see, there's some points listed here on the original. There's some points listed here on the original. It looks like, of course, there's 0, 1, because this original here has that key value. At 2, we're at 4, which makes sense. And at 3, we're at 8, which makes sense. And then at -1, I'm at 1/2. So if I vertically stretch this by 3, this is going to become 3/2. What did I do there? Multiply by 3. This is going to become 3. This is going to become 12. And this one's going to become 24. Okay? So we're going to just describe the transformation and then graph it. So this one's just going to go 1, 2. This is the main thing to get that new key value there. New key value of 0, 3. And then at -1, we'll be at 1/2. At 2, we'll be all the way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 will be here. And that's really, I'm kind of I'm out of room. All right? And so that's the new function. It just got vertically stretched by 3. All right? This one, so stretches are when you multiply. This one is with x, so this is going to be horizontal, shift, right, 3. Okay, horizontal shift, right, 3. So let's take those same values, you guys, -1 and 1/2, 0 and 1. These are the originals, 2, 4, 3, 8, okay? So that's just 2 to the -1, which is 1/2. 2 to the 0, which is 1. 2 squared, which is 4. 2 cubed, which is 8, all right? And now let's do a horizontal shift, right, 3. So add 3, add 3, add 3, and add 3. So this new graph then is going to have this kind of key value here of 1, 2, 3, 1. This key value, and I call this a key value because that's where the graph goes from kind of being, leveling off to just getting exponentially really big really quick. All right, so that's going to be where this happens now at 3, 1. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, and then let's go this way at 2. I'm at 1/2. Okay, and so we're just going to go like that. And that's our new graph, transformed g of x. Okay, and so the next one has a vertical shift up 3. Okay, so this is tagged on the end, so this is going to go up 3. Remember, the horizontals are with x and they go opposite. So I'm going to take these values once again, the originals, and verticals will affect the vertical ordinate, which is the y. So I'm going to add 3. So this will be 3.5. This will be 4, 7, and 11. So at -1, then, I'll be at 3.5. Now what's interesting here is that the asymptote is also going to switch. So this asymptote of x at this y equal to 0, if you multiply that by 3, it's still y equal to 0. So we're still leveling off here. Okay? And this asymptote was y equal to 3, and when you do something to x, that doesn't affect this. But this one, y equal to 0 plus 3, is going to shift that leveling off 1, 2, 3 to here. So that asymptote is actually going to shift. So at -1, I'm at 3.5. 1, 2, 3, 4. At 2, I'm at 7. 1, 2, 3, 4, 5, 6, 7. Okay, and that's probably good enough. All right? And that's your transformed. Okay, last little piece here is to the parent function for each graph is below. Write the parent function, then write a function for the translation indicated. Okay, so let's just look at some points here. All right, so notice parent. Notice I've got a key value there where it begins to move there of 0, 1. Okay, I can grab another one here. This is 1, 2. This is 1, 2, 3, 2, 4. Okay, so, this looks very much like a doubling. That doubled, 3, 1, 2, 3, 4, 5. So can't really see the next one, but, this is enough. You could do something like y equals a, hopefully you can tell that's a doubling, but you could go y equals ab to the x, put in this initial point. Okay, so substitute xy, this is 1. And x is 0. And so that goes to 1, and you can see that a is equal to 1. So this is y equals 1 times b to the x, and then we could sub in this point. Okay, so y is 2. And then that shows you that b is 2. That shows you, oh, you can't see it. Okay, you can see that that b now is 2. So this parent is y equals 2 to the x. Okay, so the parent function for each graph is below in the form. Write the parent function, done. Then write a function for the translation. Left 3, up 1. Okay? So left 3, I'm going to add 3 to where x is. Up 1, just plop it at the end. And we don't have to graph it, that's just the new function. Okay, let's do the same thing here. This one's a little more trickier to figure out what's going on. So let's write our parent. Let's grab 2 easy values. There's an easy value, 0, -4. Start with that, okay? Start with where x is 0. So y equals a b to the x. So -4 equals a b to the 0. That's just 1. So I got my a value is -4. Okay, now let's grab another point that we feel pretty confident about. I feel confident about 1, -2. Okay, so now I'm going to take y equals -4 times b to the x. So I'm going to use this 4 and plug it into here. And now I'm going to put -2 as y, -4, b, 1. And then divide both sides by -4. Right, and that'll be b. So I see that b is 1/2. So my base here is 1/2. So the parent is -4, 1/2 to the x. -4, 1 half to the x. So that's tricky. This would be more of kind of like a bonus-ish problem, but you might run into this in Math Excel. So that's the parent function, and now let's shift it right 3 units. Okay, so -3 on the x, and then up 1. So that's the parent, sorry, this box supposed to put both parents. There's the parent, so now I'm going to go -4, leave that alone, 1 half. So with x, I'm going to go -3, and then at the tail end of this, right, and you could even maybe put that in parentheses if you like. At the end of all of this, I'm just going to, you don't have to, but that might just look a little better, +1. All right, so that is some really good, advanced math type stuff for you guys. All right, so that is 7.2, and we'll see you next time on the video or in class. Take care, guys.